Okay, triacylglycerols. We have these terms and the abbreviation or the acronym TAG, and show the reaction of glycerol with 3 fatty acids to produce a triester of glycerol or a triacylglycerol and 3 water molecules. So this is the formation of 3 ester bonds. So you can just think of it as the top one here first, an alcohol and a carboxylic acid. We remove this hydrogen. These go off as water, and we connect the remaining part to the glycerol, and we do that to each of these. So it really is nothing new, it's just that there's more of it. And that's what happens by biochemistry a lot, is that we either have a lot more going on with several reactions at once, or it's just the same reaction that we've had before, but with a very complex molecule. So don't let it throw you. Just think in terms of the organic chemistry reactions that we've already discussed. So, sure, I'm on here, there. And then just getting this right. Let's see, 3, 5, 1, 2, 3. And in the book, they draw, leaving this carbon, they just go directly into the kink, but I like to just have a little more to work with there with that straight line before I start into the rest of the molecule. So assuming I got all of those right, and of course for my exam, if you did that and you were off by 1 bend, that wouldn't be a big deal. I'm looking for this and make sure that you understand you have these 3 ester bonds. Okay, show the same reaction using block diagrams. Now the block diagrams are going to really help us out a lot. So the glycerol, now this is the thing, you have to, I'm just going to draw the, using this reaction. Oh, and I should also say what happens for each of those new bonds that are formed. We release 3 waters. So I should have that in there. Now, I'm not going to draw the whole thing out. I'm just going to do, show the final product. Instead of drawing out this entire triacylglycerol, I can draw this in glycerol. And then attached is a fatty acid. Now, of course, this doesn't give us much information as far as the shape of the fatty acid, but we can always put in what fatty acid it was. That's no problem. But if you just want the general form, you could do this. But since each of these fatty acids that I have here has either a common name or a structure that we could easily name, you could certainly put that in here too, but I'm just showing you the block diagrams for now. Okay, now, oops, I forgot this the second part here. Show the difference between a simple triacylglycerol and a mixed triacylglycerol. So, let me make sure that I do have. Now notice that the fatty acids that came into this system to create this triacylglycerol all have the same number of carbons. There's no double bonds here. Let me just make sure everything looks good, and they're all the same. So that's a simple triacylglycerol. And if you wanted to make it mixed, all you have to do is put 1 double bond in there. Of course, that should be cis, but I'd say that's all you'd really have to do. But if you want to make this chain a couple longer, all you need is 1 of the fatty acids that came in to be different from the others. So make them all different by putting in, making each of the fatty acids different. But as long as 1 is different, that would be mixed. Describe the differences between fats and oils. Alright, so fats are composed of triacylglycerols in which saturated fatty acids predominate. And there's exceptions to each of these, but that's just what we're talking about in general. Oils are composed of triacylglycerols with larger amounts of mono and polyunsaturated fatty acids, which explains why fats tend to be solids at room temperature and oils tend to be liquids at room temperature. You can always solidify pretty much anything, but oils tend to be liquids because of that unsaturated characteristic of the triacylglycerols. Fats are obtained from animals in general, and oils are obtained from plants in general. Of course, fish, we have fish oils as well. So again, this is just general ideas. And then pure fats and oils are colorless, odorless, and tasteless. So any oils, naturally occurring oils that have a flavor or a smell to them, same with fats, that's just other compounds that are part of that system. And it's, you know, when they're made by plants or by animals, they're there for a purpose. They have there's some part that they play, so they're not usually isolated components that are just separate from the rest of the body. They work in tandem with the rest of the body, so we'd expect that there are other things that may be mixed in there. But on their own, they have no color, no odor, and no taste. Okay, now we have a whole set of important facts about triacylglycerols. So I just listed them here. You should, and it's hard not to do this kind of potpourri approach where you just put a bunch of little bits and pieces. But I just want to make sure they had all of these concepts down, all of these little facts about triacylglycerol. So let's go through them. The term fat or dietary fat is used as a substitute for the term triacylglycerol. So and a dietary fat can be either a fat or an oil. Current dietary fat recommendations limit total fat intake to 30, 15, 10, and 10. They should be 30% of the total calories, with up to 15% coming from monounsaturated fat, 10% from polyunsaturated fat, and less than 10% from saturated fat. So I'm not going to kill you on these percentages, but you should have the basic idea of where they're coming from. Relative to one another. You should know that saturated fats are considered the bad fats. They appear to increase risk of heart disease. Monounsaturated fats are the good fat, decreasing the risk of heart disease. They reduce the stickiness of blood platelets, reducing the chance of forming blood clots. Polyunsaturated fats can be either good or bad, and some decreasing the risk of heart disease, but it's been shown that they increase the risk of some types of cancers. And it's hard to say because there are always exceptions, and there are many exceptions that have been found in large groups of people in different parts of the world for various reasons, sometimes known, sometimes unknown at this point. Omega-3 and omega-6 fatty acids reduce the risk of heart disease and are found in large amounts in many types of fish. Essential fatty acids are needed in the human body but must be obtained from food, so they cannot be produced in the body. Or if they're produced in very small amounts, they need some sort of supplement. Now, linoleic acid and linolenic acid, get this on here, are two essential fatty acids that have to be brought into the body. Linoleic acid is omega-6 fatty acid, 1, 2, 3, 4, 5, 6. Linolenic acid is omega-3 fatty acid, 1, 2, 3. They are used for membrane structure, and serve as starting materials for many different longer chain omega-6 and omega-3 fatty acids for the body. And if you lack these two fatty acids, it can lead to reddening of the skin, infections, dehydration, and so it shows that without these fatty acids, our bodies are incapable of producing them on their own, and so they are something that we need to ingest. I think that's it for the important facts. Let me see. Yep.